Hi everyone, thank you for coming. My name is Timofey. And I'm gonna spend the next hour or maybe a bit more of your life talking about machine learning and how we squeezed it into our products, in particular our IDEs. So I'll be very short here. So JetBrains is if you're doing something with code, I guess you've at least seen our products. We have a lot of them. We have most of our products that people know us for is our IDEs, but we also create products for non-developers. We also create Kotlin and other things, very cool stuff. If you haven't tried it yet, go ahead, but not right now, after the talk. And yeah, here's the QR code with a lot of fancy infographics about our company and how we are. I tried to count the countries where we are now represented, and I counted almost 40 of them, but we have development offices in maybe 6, 7 countries, including Cyprus. So I'm very glad to see every one of you today. We also have a bunch of research labs. I represent a machine learning for software engineering research lab. And I guess we do all kinds of data-driven stuff applied to software engineering. But if we talk about the company in general, I think last year the IntelliJ IDEA tool turned 20 years old. So the company is a bit older, but perfecting one IDE for 20 years is a lot of effort, and a lot of things have been implemented, a lot of different tools, static analysis and others. But now the trend is that we have lots of data publicly available. So GitHub basically changed everything, and now we have a lot of code that is accessible, and we can do all this data science magic with this code. So let's see what we can do with it. I don't know how familiar you are with machine learning, but my talk today would not require a lot of background knowledge. I don't have any formulas and stuff like this. So machine learning is a current trend, and you basically, if you're using your mobile phone or any other product or software, you use machine learning in essence somewhere deep inside. So applied to software engineering, we could use it basically everywhere in this very complex process of creating software. Here I put just some examples of what activities could be enhanced using machine learning. And those activities are only connected with creating code. So I don't even touch collaboration activities. I don't touch communication and other things that also could benefit from applying machine learning. At JetBrains, we always wanted to create the best tools for developers, being developers ourselves. We are trying to make life of developers more productive and more bright, and remove all the routine things that we have, replacing them with smart assistants. Before that, they were based on different heuristics, and they were implemented manually. Right now, we are as the whole world does, we are migrating towards more data-driven approaches. So our philosophy is to enhance developers, not to replace them. Currently we have, with the current success of large language models such as GitHub Copilot and others, and Codex. But when you talk to an AI professor, they mostly, when they think about applying machine learning to software engineering, they instantly come to a point where they are trying to replace programmers, basically with some fancy neural model or something else. And I guess the most popular task when we're talking about applying machine learning to software engineering is code synthesis. So basically take a description in a natural language and generate code that does what this description says. While I genuinely believe that in maybe 10, 20, or I don't know, 50 years, we'll have models smart enough to do that, and the profession of software developer would evolve into something else. Currently, we are focused more on software like assisting tools, software that helps developers being more productive and basically more happy about what they do. Okay, so machine learning for software engineering is a specific niche, and it's a bit different from natural language processing and others. Source code, yeah, today we're going to talk more or less about source code, but ML4C is not only about source code. Yeah, we have a lot of textual data such as issues, bug reports, pull requests, discussions, and stuff like this. And it's only like there's a lot of tasks that machine learning could be applied to using this data. But today we're going to focus on source code. I've even seen a paper where researchers wanted to find duplicate codes, code fragments, and they did that taking screenshots of the code and using like CV to compare those screenshots. They even got pretty decent results, but I think they just were, I don't know, having fun or something. So, but again, you could apply CV to this domain as well. For example, there are screenshots of different, I don't know, bugs that happened in some tool, and sometimes users take screenshots and attach them to issues. So getting the text and the meaning of those screenshots could be one of the tasks, and as far as I know, we have some ongoing projects in this area. But yeah, source code is text, and you can treat it as text. For example, you can apply like NLP models, but source code is more than just text. It has its inner structure, hierarchical structure that has some kind of semantics and dependencies, and that is put there by developers for some reason. So ignoring this, well, might bring you to lesser results that you can have. As I said, GitHub basically turned everything, and now we have like hundreds of millions of repositories in basically every programming language that we can use. But again, it doesn't mean that collecting a decent data set is an easy task, because, well, you have to, your data set should be good. It should capture the characteristics that you're trying to your model to learn. And like making sure that your data set collects, that you collected contains all those characteristics is a tricky task, because there is a lot of junk on GitHub, and filtering this junk is not always that straightforward. So another challenge here is that those models, those, well, let's say, let us be frank, neural models that everyone's so fancy about these days, they have to be integrated into an IDE or some other tool. And that sometimes is a problem. If we talk about some server-based product, for example, a continuous integration server, there might be no problem at all, because you have like this model running somewhere in the cloud and you use some API to access it. But if we talk about an IDE, which is usually being run on a client's computer, with all those restrictions on memory and like time and computational complexity, then, well, it gets very tricky to deliver those large language models to end users. And software developers are not very fancy of machine learning. Maybe you disagree, but when we are trying to give developers some assistance to use, they have to be like very precise, because this is a black box that is hardly interpretable. And when this black box tells, like, let's be honest, a very smart, usually person, that they are not correct somewhere, they kind of question their ability to write code or something like this, they get very angry very fast. So we have to be very careful about false positives. And if you read a paper and see like some model being, I don't know, 95% accurate, that's a terrific result for a paper and everyone would be happy. But in real life, it means that every 20th of, in one case of 20, it would provide wrong answer, and developer would be frustrated, and they would not remember all the good things that the model done for them, but they would be very, very annoyed by those false positives. So yeah, today I would like to present you 2 case studies of like 2 stories of the products where machine learning turned out to be pretty useful. Those are just like handpicked two stories, and there are lots of others, but I thought that they would be interesting enough for you because one of them is a tool that I think every developer uses in their everyday life, and it would be nice to look under the hood and see how it works when you use it. So just taking a step back, the pipeline of how things are done at JetBrains it looks a bit more of a pipeline of a startup company, because with those data-driven features, it's not clear what the user wants. And sometimes we have to quickly create a minimal viable product, test it, like bounce it off people, see what they think, would they use this prototype or not. Being a company that develops tools is easy for us because we don't usually have problems finding people to talk to, because you go to like a different room in the office and see and find someone who is interested. And sometimes we understand that those prototypes are not good enough. Sometimes we understand that they are, like, the idea is nice, but state of the art is not good enough, and there are like a million different reasons why this prototype should be buried. But sometimes we iterate, sometimes we like bury those projects, and at some point we understand that this is good. That there's something in it. This feature will be worthwhile. So at that point, this prototype is re-implemented or being thrown away and implemented from scratch, and being pushed into an existing tool. So the first thing that I'm going to talk about is code completion. I think that we can hardly imagine an IDE without code completion. So I guess everyone knows what it is, but if you don't, that is a suggestion list that appears at some point automatically or by choice, that shows the best suggestion that is applicable in this current context. So what is it? What is code completion, and how should be implemented? But first of all, sometimes we have to, when we're thinking about some feature or some prototype, sometimes we have to take a step back and understand what are the requirements of this prototype. What do users want, and how should we approach this task? So to understand how code completion should work, let's ask this question: is this suggestion good? So you might say that, well, it depends on where I apply this code completion and where this in the project this suggestion comes up. But as we will see soon enough, I would argue that this suggestion list is completely useless. So let's take a step back. What do we want from code completion in general? The first idea that comes to my mind is like, we want to type less, right? We start typing, and then we have some suggestion, and we like click tab or use a mouse or whatever, and we get this long and meaningful identifier name being completed. All right, but if you ever written a code, how actually what's the ratio of the time that you type and that you think? So I know people who type faster than they think, and sometimes it gets them to situations when they have to apologize for what they typed in some social networks or whatever. I know programmers who type faster than they think, and sometimes, well, I guess it would be nice to apologize for every bug that you put into your code, but nah, no one does that. So my point here is that we type. The speed of typing is not the thing. Is not the bottleneck. Is not the thing that we should speed up. And developers think, at least they should think, more time that they type. So getting fewer keystrokes is, I guess, not the main issue. And we want to reduce the cognitive load. That we can do that by in several scenarios. For example, spend less time thinking. And another scenario that often comes to mind when talking about code completion is project exploration. For example, you just want to see what is available. So you press a dot or you press command space, and then you see what's the suggestion list and what is applicable in this particular context. So when we have this understanding and we get back to this wonderful snippet list of suggestions, then we understand that basically what it does is it suggests you a 2-letter keyword, a couple of types, and two very simple things from a library. So basically, it doesn't solve any of the problems that you want to solve with code completion. Let's overview how code completion is done in our IDEs. So first of all, we get the suggestions. No, I have to get a step back. So because of those restrictions and ideas, we pose the task of code completion as a ranking problem. So a lot of people, especially in scientific papers, they look at code completion as a code generation problem. So basically, when you need the next token or a phrase of tokens, you run some code synthesis model, and it shows you like the code that should go next. But yeah, since we aiming at accuracy, and we don't want developers to get some randomly generated code that has nothing to do with what they want, we pose this question as a ranking problem. So we generate like correct suggestion lists and then rank this list. So for generation of those options, we use so-called contributors. So every contributor generates suggestions based on their scope. So one of them generates keywords, one of them generates class members and like methods and so on. So having all of them run together, we have a list of maybe 800 options, which we then need to sort. Generally, first of all, we use heuristic-based sorters. So for example, if a person typed something, some letters, we should honor their choice and only show them options that contain those letters, right? Another thing is proximity factor. So when we are considering different options, we put the ones that are closer to the current place in code than others. So for example, if we are somewhere inside the method and we have a variable that is being declared just in this method, we should put it on top, and if there is some, I don't know, class with the same substring in their name, then we should put it lower. And for IntelliJ IDEA, there's about a dozen of these sorters that have been developed for the past 20 years. They handle a lot of corner cases. They're very accurate. But you know, if you're developing an IDE for a new language, you wouldn't want to spend like 20 years developing your sorters. So basically what we can do now is apply machine learning to rank those. So in the beginning, we just generate everything. Then we rank them according to these heuristic sorters, and then we, on top of them, we apply machine learning to re-rank them. If we're developing a new IDE and we don't have enough handwritten heuristic sorters, then we can just skip this part and just apply machine learning on top of just the raw output of the contributors list. Okay, the pipeline of code completion in very simple form looks like this. And we have to start with collecting data. Let's talk about that. So the obvious approach that we can take in collecting data for code completion is just going to GitHub. There's plenty of projects in every programming language written by all kinds of people of various level of programming skill. So let's take a random project, let's take a random file in it, let's take a random line in this file, take a random token in this line, take a random position in this token, remove the rest, and try to predict what we deleted. That is very easy, piece of cake. You just write very simple script that grabs that from GitHub, and you get theoretically infinite data set. But is this data set what we want? Because first of all, the data is, well, very much synthetic. Yeah, it's not the data that we get from people. As you noticed, I didn't mention people at all. We are going to GitHub and we're using this version control history. First of all, people don't commit, they commit good code to Git, right? So the code that you're not ashamed of, at least at some point, or maybe forced you to commit it. But anyway, you don't have, it's code that passes unit tests, that is syntactically correct, usually. And this is not the code that you write using a series of edits. Because in each of these edits, a completion window would appear. But we have only the last snapshot of the code that people decided that is good enough for them to push to Git or whatever. So we miss a lot of developer activity. We don't know how developers wrote this code, how many times they deleted everything and wrote from scratch. Maybe this is the millionth iteration of their, maybe they spent a week writing this 5 lines of code. Maybe it was 3 files of code and then it shrunk down to 5 lines. We don't know that. We have only the result, and this result doesn't actually tell us much because, how should I put it? There was not an edit sequence that produced this. So no developer actually wrote this code from scratch. It could have been written in a very weird order, and we don't know that. And if we do that, so there was 3 years back, there was a paper at one of the major software engineering conferences where Microsoft research guys, they instrumented Visual Studio and they collected what actually users auto-completed in their, using their Visual Code. And they sampled GitHub to get this kind of artificial data set, and they compared, and they found out that the proportion, the distributions of entities is very different. And if you train a model on this artificial data, it would learn something, but I guess it wouldn't be what you wanted it to learn. So this way is very simple, and a lot of people in the academic community follow this path, but this is not what you want to achieve. Another thing is to, well, you could say, you're JetBrains, a lot of people tell me that. You're JetBrains, you have millions of people, so collect their code and train on it. The thing that I say them back is, do you want me to collect your code to train on it, so would you give it to me? Because, it's illegal, pretty much, because, I spent too much time preparing for this talk. This is OpenAI's DALL-E for JetBrains developer in jail. So this is how they see us in jail. So yeah, it would be wonderful to do that. I'll be honest. So I would love to take all of your code and train my fancy great models, and they would be wonderful. But no one would give me that code, so this is not the way to go. So what do we do? we use not the code, because we cannot collect it. We use the descriptions of the code to train the models, to get features to train the models. So when a user starts using the IDE, well, we cannot send their code to our servers, right? But we can send features that we collected, and those features that are anonymous enough not to reveal anything that this code represents. So basically, we get a vector of numeric or enumerable values that describe what's happening, that describe the context, that describe user actions, and that describe basically everything that we need to know to understand how this code completion should work in this context. I'll show you some examples. So we are not sending any code. Because it's important because the thing has been in our product since 2020. So it's a bit, if you decided just to stop using our products because we send your code, well, it's way overdue. So yeah, yes, we're not sending any code. So we have a very strict policy of filtering everything that comes to our servers. And the default policy is like take the only thing that we can accept are the things that are allowed. So everything else is being rejected, and it's very hard to change this policy. I tried, and yeah, it allows a lot of bureaucracy with lawyers and like legal department to change this policy. So an example. For example, you're writing a booster function, and you type this random.c. So in this context, this is what we get from you. First of all, this is an automatic pop-up in comparison to the pop-up that could be produced by hitting command space, for example. And this is a feature for us. And you know, this tells us nothing about your code. So the indentation is 2. This is important for Python, but especially for Python, but for different languages it could be important as well. Prefix length is 1. So we don't save the character itself, but we save the length. So it's also a numeric value. Parent type of this is loop, which is a numerable value. Invocation in the middle of the line and not in the beginning. Invocation happened after a dot and not like somewhere else. For example, this window appears and user spends about a second and chooses the second option being the correct one. So what we record is that the delay is 1100 milliseconds. Again, a number. That the user action was to select something from the list, and it was the right one. For example, another action could be canceling the list by hitting escape, or sometimes it also happens typing the correct version. So sometimes it's faster to type than just to select. And we log these events as well. And we also log a lot of things about every item that we have in the list. For example, for the selected item, we say that it's 7 characters long, the prefix matched 1 character, and the match location is in the beginning and not somewhere in the middle. Yeah, we also log that this is a library call, which might be important for us. And there are like dozens and dozens of such features that we collect based on the language, based on what users do and what suggestions do they get, and so on and so on. So we get a lot of such features. Every one of them, and basically all of them together, they don't tell us anything about your code. So this is just a description of what happened and how this completion engine worked. So a few interesting features to note is, features that we were surprised to see very important in the trained models. So for example, when I showed you this pipeline of code completion, I told that for new languages, we don't have heuristic sorters. But it turns out that for Java, for example, that has a lot of heuristic sorters implemented, their input is very important. And the position that heuristic ranking gets to a specific item turns out to be a very important feature. Also, we don't, so if we throw this away, we could get something like this, which is horrible because everything is mixed. And we reorder only top 5 of the suggestion list, and then we go with groups created by those heuristic orders. Yeah, another thing that turned out really important, which was fun, was that if we're trying to predict something, we could look for something that already is in the file, and even in the similar context. We define similarity based on n-grams. Again, very fast and computationally like very lightweight way to compute similarity, but that shows us that basically no one tries to follow this don't repeat yourself principle, which is sad, I guess, but if a person used some identifier in a specific context in a file, they're very much, the chances that they use it again is very high. That is our observation. So to sum up, our data collection gets us to the point where we can collect data from user sessions. And since they're not synthetic data, they're like taken from real users and doing some actual coding, we can do both offline and online evaluation. But there are several problems with that. First of all, you need time, and basically you need a completion engine to collect such data. So you need a model to train that would be like working for users, collecting data for you to train the model. So you get this chicken and the egg problem. And the second time, I'll get back to that in a moment, but the second problem is maybe even worse because, for example, when you're training a model and you see some problem in the data, you just go and look at the data. You see what was wrong. You look at the data and you get some hypotheses and you test them. You maybe throw this data or something else, but we cannot do that. We don't have like we cannot look at the code and see why this vector is like this, why this model doesn't work well with this. And this makes the debugging of the model very hard because we don't get actual code that these vectors were created from. For example, I have an example for you to highlight this. At some point we noticed that there's some group of people that very rarely uses anything from the completion list. So, well, why? We tried to investigate, and well, we got that they were not different from different. Were different by other people. So they used, the activity was similar. They used the same programming languages. They even got their completion lists as frequent as others. But for some reason, this group of people, they didn't choose anything from these lists. Do you have any ideas what they could be? So completely normal people not selecting anything. Yeah?
Maybe just they didn't want any autocomplete because it distracted them. Like they were checking, they didn't really pay attention to whatever pops up.
We should have a survey, right?
Yes.
Yes, the suggestion was that they were distracted. No, it was much more simpler. They had this option checked. So for some reason, there are people that are still using alphabetical sorting for completion options. So yeah, when we got, it took us a while to get why this happened. And then this idea came out to us, we checked it, and we were right. So we added one more item to our feature vector that says if this checkbox is active. And when we're collecting data from people, we ignore suggestions from those people because they don't make any sense.
Sorry, can I ask a quick one? Why do we even need such a checkbox? What bad will happen if we remove it?
The question is what bad would happen if we remove it. We get biased data.
No, like, I mean, not even for us, it's like developing code completion, but like for when such a code, such a checkbox in IDE is
because there are a lot of people who use it. And they started complaining very loudly on Twitter and stuff like this when we tried to remove it. For some reason. Yeah, there are people like this who still used to that and they just refuse any technology on top. So yeah, we had to like backward compatibility thing. All right, so let's get back to this chicken and the egg thing. So we need the model to collect data to train the model. This is the problem. So this problem is solved with our early access program. All of our products, they have this early access program where several times a year before the release happens, we invite people to join and test the pre-release versions of our products for free. So you can sign up. And basically we use, but yeah, you agree to special conditions. One of them being that we collect anonymously, we collect data from you, and we use this data to, well, do all kinds of stuff, including training machine learning models. This data is still anonymous. We still don't collect any code, but we don't collect those logs from actual releases. We collect them only from EAP releases. Okay, so now we figured out the data pipeline. Let's see what we can do with that. Requirements for the model are the following. So the code completion thing is very conservative. There are even people who are conservative enough to check this box and sort everything alphabetically because it was like this in 2003 or so. But anyway, our model should be lightweight enough and fast enough to be able to run on developers' computers. So this is not the feature that could work in the cloud or something. This should work out of the box on every computer that the IDE would be run on. So it should not download anything like from the internet. Maybe the user doesn't even have the internet. So it should work out of the box. And we came out to a conclusion that we have to work with decision trees because they are lightweight enough, they are efficient enough. So we used KatBoost to as machine learning models. I'll be very brief here. What is the metric? What should we train a model? What should we teach a model to do? This is very interesting thing because this code completion ranking might seem similar to, for example, what search engines do, right? You have this list of suggestions, and the most relevant should go up, right? But there are differences, and for example, in search engines, we should like measure this as a matters of grade. For example, you have this subjective importance of this item, and if you put it somewhere in top, it's all right. Then the user sees it, and then they click on it, for example, and do something else. If it's not important, then you could put it somewhere in the bottom. But here, I would argue that the case is different. For example, let's compare those two options. We have like a bunch of suggestions, and the correct one is at the very bottom, and it's somewhere in the middle. Is this second one, the right one, better than the left one? According to the model that we trained with RMSE or something, root mean square error, the second one is much better because the correct one is higher and the number is bigger or smaller, whatever, and that is better. But from the developer's point of view, they're very useless. They're completely useless. The correct thing is not on the top. So the very crime that a model can commit is not to put the correct thing at the very top. And if we change this from average position to top-only position approach, this has a very, very, very high impact. So we took a loss function from a paper from 2007 that was implemented at KatBoost, and it instantly increased success rate by 10% just by changing the loss function. If it makes any sense to you. If it doesn't, let's move on. Okay, now we trained the model. Let's see how it works. And there are two types of evaluation that I've talked about. There's offline and online evaluation. For offline evaluation, we use like standard recall at top K metrics. And this is actually the tests how the model will work on the data that it hasn't seen during training. So we collect data. Again, we collect it from users. We have 1 week in the fall of 2020. The users of PyCharm, we collected completion sessions from them. It was a training data, so we collected a bit, something similar to 55,000 sessions from 2,500 unique users, and we use it for training and tuning. And the next week, we collected the data for testing. So as we can see, machine learning model works better in terms of recall than heuristics-based model. It doesn't actually mean that it would work, like it would solve the task of code completion better, but at least we know that there's some hope. So we should proceed to online evaluation. So online evaluation actually means that we actually put this model to actual users and measure everything that we want. So that is a very different evaluation, and there are different things that we can measure. So we measure time to result, we measure percentage of successfully completed tokens. So in this scenario, these metrics actually make sense because this data is not synthetic. It's actual data produced from actual users. So we measure that. Yeah, and again, we used 66 and 74,000 completion sessions from actual users in a A/B experiment, and we got statistically significant decrease of different metrics. So type select here means that a number of sessions where developers actually had to type the correct version while we had it in a suggestion list. And typing actions is a number of symbols that the users typed before they selected the correct one. So the lower the better, and we see that we have like, it's hard to judge, I guess, the impact, but the numbers are lower, and other metrics that we used also showed us that this machine learning model performs better. But okay, yeah, okay, we've trained the model, we beat everyone, and so we're not naive enough to believe that this is the best model, and this model should be used by, I don't know, our grandsons. So we have to have a reproducible and reliable pipeline of updating a model and of keeping track of how these models are. So we do that in A/B tests, and that might be a bit tricky for desktop applications because it's very easy to have an A/B test for I don't know, web page or something. But here we have a desktop application, but anyway we split users into buckets, and we show different models to different users, and we then compare the result, coming to conclusions about the model's performance. So in every EAP release, we ship several models in the IDE, and then we, like as I said, we put users into buckets and show different models to different buckets of users. Here, for simplicity, I showed only 2 models, but in some experiments, they could be like more, like 8 or something. So one of them is the baseline, is the previously trained model that we had from previous A/B tests. And the rest are new experiments that we're trying to compare to this baseline model. During this test, we collect data for the next EAP release. So while EAP release has two goals. First of all, we compare models, and we collect the data set for the next one. So we select the best model, which turns out to be ML I+1 for some reason. Then we train a new model based on the data collected from a previous release, and that happens on and on and on. So basically, this is the repeatable pipeline that we apply every AP. That allows us to collect data that is up to date, that contains every new trends in how developers write code if they change for some reason. And that way we know that the model that we're using right now is the best model that we can train with the best number of features that we can come up with and stuff like this, and so on and so on. So we had this in production since 2020, actually, and for like most of our IDEs and most of our languages. They're also, okay, takeaways first. What's the outcomes of this? The grand idea that I wanted to share today is that you can train a model without seeing a code that it works on. So you could use descriptions of the code instead, and train your model on features produced from those descriptions. We use very small models that only 1 or 2 megabytes large, and they work good enough, even compared to large language models that we tried. And yeah, for those tiny models, we don't need like millions of data points. We can have only several dozens of completion sessions to train models. Selecting a good target metric is crucial, and but I guess every practitioner knows that only an online evaluation can tell you if you succeed in solving a task or not. So just getting a number that is higher than another number on your data set is not enough. So right now we're trying to expand this idea to different tasks, not only code completion, but this idea of training your models not on the code itself, but on the features built from the descriptions of this code is rich enough to be applied like for other tasks as well. If you're interested in technical details, there's a paper about this, which we presented a month ago in Singapore at a software engineering conference. It has a lot of details about what happens there. I think we will share the slides somehow, right? So, all right. The second, the question was whether it's possible to have an in-house solution of a server that is used for some company. The answer is yes, it's possible. And I think that I have a slide maybe very close to what you're asking. Well, the answer is yes, but not with this, because it doesn't make any sense to do that just for like this kind of completion. Because when you apply like a large BERT or something like that, GPT-3, for just a single token completion, you would get a very small increase in efficiency, but you would have to like rent a server and stuff like this. So the trade-off is not that great.
But if you talk like about full armor,
yes, that's a different story. I have a slide about this in the end of my presentation. All right, so the second story that I'm going to share is about the Grazie project. So the motivation behind this was the following. We know how to do things in the code editor, right? We have a lot of experience with code, a lot of code completion and different other things. So let's use this experience to work with natural language texts. So for example, create all kinds of completions, suggestions, fixes, and others, but with natural language inside the IDE. So for example, it could correct you when you write your comments or commit messages or something like this. So the idea of this project was to create a platform that would be able to do all kinds of stuff with natural text and make it so that it could be integrated into our products, IDEs, and others. Yeah, so there are two approaches to that. As we just discussed, we can have a local model, machine learning model that works on a developer's computer, and we could have a server-side solution that is hosted somewhere. So with those cloud-based or like server-based approaches, there are clear pros. You can use any model that you want. You can scale it however you want. But if it's not an in-house solution, then you would have to send your code somewhere, which is not very great from a security point of view. And the costs of having this cloud solution might be just too high. But as a local solution, you could use only the smallest and the fastest models, but they are not scaling well. So what did we choose? We choose both. So first of all, a local solution works as a fail-safe option. So we have a very simple model, usually also based on trees and random forests, that works, that operates as a basic version of the product. So it works, it does all the things that needed to be done, but it might not be the best quality of server-side solution. And then, if a user agrees to send their code, or if they have this ability or anything else, they could apply for a cloud solution, and then have all this mighty force of large language models and stuff like this. So let's talk about several examples and see what could be interesting about them. So natural language completion is very, very familiar to all of us, I guess. If we used Gmail or something else, we know that it tries to help you write faster, showing you different options. But there are two ways code completion could work, text completion could work. So the first scenario is exploratory text completion, when you just want to see what's available. And in that case, the user interface should be this list of suggestions that you pick from. But if you're willing to just type faster, this is not the option, because it would slow you a lot. In this case, showing this gray text that you could press tab and would appear is much more convenient. So there are different user interfaces for these different scenarios. Again, this language completion model is basically a GPT-2 model, which what it does, it generates text. It doesn't know anything about this text. It could generate very offensive text. It could generate garbage. So we actually have to filter that and make sure that the output of this model is good enough for us to use and to show to the users. Because there are several screenshots on Twitter when this thing actually suggests funny but very offensive stuff. And yeah, every one of those cases was handled. There's a person in the audience who actually wrote a long list of offensive words for the developers of the thing, just for them to have a vocabulary to filter. So yeah, and another thing here which is worth noting is that a lot of domain-specific models actually showed very, very, very high usefulness. So for example, we have a specific model for academic writing, for IT. So all those slang languages, they benefit from their own specific language-specific models. About grammar correction, the first, I think this was the first task that they tried to implement. So the idea is to find and correct grammar errors in the text. And first of all, they tried to build on top of Language Tool, which is a well-known existing open source tool, which is not very efficient and effective. So they tried to tweak it and optimize it. So at some point, they tried to replace parts of this tool with their machine learning models. But that didn't get the quality that they needed. So at some point, they threw it away and replaced it with deep learning approaches, which basically did sequence tagging tasks, which means that finding the word in the sentence that should be replaced, or even use generative models that allowed to replace parts of those sentences with new ones. So for example, that applied paraphrasing and different things. So yeah, the idea here, I'm just trying to speed up a little because I'm running out of time. The idea here that they gradually replaced existing tools that work, and having a prototype that works badly is a lot better than having a prototype that doesn't work. Starting from a thing that works maybe not ideally as you want, and gradually moving towards a better solution is always better than creating the best neural network or something else, but it doesn't work. All right, but having all those fancy models and having them in a JVM environment, such as our IDEs, turn out to be a very tricky thing. So yeah, everyone trains neural models in a Python environment, right? but JVM environment is different. And how should we use those models? We can well, say the user should install a Python environment with their IDE, but that would be a bit too hard, I guess. We could bundle the Python environment with our IDEs, but that would be horrible as well. There are several libraries here, mentioned here, that allow you to inference your models in Java. But as you can see, they require a lot of space, and they didn't work as correctly as we wanted them, as stable cross-platform. So at some point, we came to a conclusion that there is no reliable way for us, no existing library or framework that allowed us to inference models in a JVM environment. Those models are that heavy because, well, basically deploying for J allows you to train models in Java. And we didn't actually needed that. So we needed to inference the model, not train them. We came to this Onyx thing. Basically, it's a format that allows you to represent your computational graph. And then, you could use this format to represent models trained in different libraries. So it gives us this unification. And there are several libraries that allow you to inference models represented in this format. But for Java, all of them use Java native interface, JNI. And this turned out to be a pretty big problem for us because, first of all, there's some problems with reliability. And the second one, JNI actually copies the memory, which turned out to be very slow for us. So we had to develop our own library, which used Onyx and actually implemented Onyx operators to inference neural networks. Since this library is written in pure Kotlin, we don't have any JNI problems. We have a very lightweight library. And we have our own n-dimensional arrays that I'll comment on just a bit later. So this is an ongoing project. We still are implementing and adding new operators, but now it is able to inference most of existing large language models that we have. So why do we need our own arrays? It turns out that from a specific size of an array, Java is not very efficient with CPU caching. So we just cut the arrays in some tiles and use these tiles to do a lot of matrix multiplications. So for example, if we see here, we have 5 times faster arrays that work 5 times faster than standard Java arrays in matrix multiplications. So this is the results for 100 runs. And since inference is a lot of matrix multiplication, we get very nice boost of inference time. For example, for Grazie completion models, for a distilled GPT-2 model, we have these numbers, also about 5 times acceleration. So remember, I showed you that an ideal completion model would operate under 30 milliseconds or less. Here we have 56 for the smallest code context, which is kind of comparable. But anyway, even 200 milliseconds for the larger context is much faster than just with standard Java arrays. And for BERT, for quantized BERT, we have, again, almost 5 times an acceleration. And again, even for the larger context, for the number of tokens of 512, we have 350 milliseconds or so, which is kind of all right for a local model working on a computer of the developer. So yeah, now this library is being used in several projects in JetBrains. It is open source, so feel free to use it if you need to. And the takeaways from that is that Building a fancy model is very interesting and very exciting. But going from simple solution first actually is more reliable and gets you the feedback you need, the experience and the knowledge you need to build those large, fancy neural models when you get to the point that you need to. So I didn't say anything about the data set, but all right. So yeah, apart from developing the model, we had to collect our own data set using human assessors, which was very hard. It required a lot of time and effort and money. But at the end, you know, there are a lot of data sets with natural language, but they're not very friendly to commercial use. So yeah, we had to collect our own data set and invest a lot of time and effort in this, but it actually paid off. And regarding the last bullet here is that sometimes you understand that developing, you don't have the tools needed to solve your task. And it's always frustrating because you're trying to go to, I don't know, to this project's GitHub and post some issues and wait for the maintainers to implement them, and you always get frustrated when they don't. But this KInference project, it sounds very hard, and it is hard, but it was developed by one bachelor student in a year and a half. So this was a very bright student, and now he works in this Grazie team. But anyway, it was not a team of seasoned engineers. It was like one engineer and one student doing all the heavy lifting. So even if this task seems very hard, sometimes you can have a student doing that, which is very nice. OK, so to wrap up, I have this diagram taken from a PhD of my colleague, which shows a life cycle of a data-driven feature. So you have to have data. And yeah, always, sometimes people write papers and prototypes presenting new techniques, showing that we can do code completion, we can find bugs, we can do whatever we want. But creating a tool from this is a lot of extra work. And just writing a paper showing that your model is better than anyone else's, or that you succeeded in doing that, might not be the thing that could be used in practice. And building a tool on top of that requires a lot of extra effort. And having this tool implemented as a data-driven feature is a different step that requires even more effort and sometimes a lot of help from the vendor of the tool. Yep. So here I say a lot of we, but this work has been done by different teams at JetBrains. So the machine learning and in code completion team developed the code completion part that I've talked about. The Grazie team and our own machine learning for software engineering research lab developed the KInference library. So yeah, I should thank them because I'm just taking the credit for their work. All right, so thank you for having me. This is the feedback form. Please say something nice about me or not. This is the contacts where you can find some information about our team and me. If you want to ask something or I don't know, whatever, just send me a message. And regarding to the question that we have during this talk, we also have a prototype plugin for full line-based completion. So not only in this talk we talked only about single token completion, but you know this GitHub Copilot thing and others, they going further. So we also have a prototype. If you're interested, please go to install this plugin and use it and give us your feedback. OK, so with that, I'm done. Thank you very much. If you have any questions, go ahead. The question was whether this plugin works on your computer. There are several versions of that. So yes, I think that this one works locally, and we also have the version that uses larger models. You want we have this like internally tested because we don't really want to send any code. Yeah, but if you're interested, just ping us. Yes, but it's completely different. Yes, the question is, what is Kotlin DL and how is it different from the KInference library? So Kotlin, the approach Kotlin DL tries to take is that all data science should be done in Kotlin. So they actually target training the models and inferencing them. And we're not like we're not interested in training the models. So our approach is that we could train the models using any Python library that you're familiar with, and then use this library to inference the Onyx format. So they kind of similar, but they have this different philosophy and different approach to that. So the tooling is also very different.
Okay.
The question was, if I understand it correctly, did we see any improvement of the new machine learning based model compared to the heuristic model?
Yeah, and
from different versions of machine learning model in time, right?
Yeah.
Yes, actually every AAP release, something new is being added to the model, some new feature, because every time we experiment with like how we can improve the model. So we remove features, we add features, we try to like experiment with data collection, but it's a long cycle. So if you want to add some new feature to the model, first of all, you have to add the collector of this feature, then wait for the next EAP release, then train the model and see if it works better. So it's not like you can experiment very fast. But yeah, generally the quality of the models goes up. I don't remember these guys saying about drastic increases because, well, it's hard, the quality is also very high. So it's hard to get like twice, the model working twice better as it was. So the increases are always very, very small, and but they happen all the time. So yeah. It would be interesting to see, some new trends in how people write code and how it is being incorporated in the models, but you have to have code for that. Just having the features is not enough to see those trends. The question is whether we have some data collection that includes some code collection internally. I would say no, because this code would be very biased. Because yes, we are developers, but we are very specific developers. We're developing IDEs, and it's not generalizable to all developers out there, because people, even if people use Java or Kotlin, they use different libraries, they use it in different contexts, so our experience might not generalize well to them. So for some experiments, it makes sense to collect some data internally, but I think that we are not large enough and not diverse enough to understand how the rest of the world feels about what we develop.
But that's what Facebook did. They have a paper doing exactly that. That's still not anything. Well, they did collect a bunch of internal code.
Yes, Facebook has a paper about how they collected code internally, but Facebook is much larger, and they are not developing just IDEs. We are not developing only IDEs as well. We have other projects, but a lot of the code base, the major part of the code base is IDE related. So the question is, do we collect the percentage of completed code? I think not. There's in this project, there's this, because the goal is not to complete everything, I guess, but to be useful to developers. When we evaluate that kind of approaches, the evaluation metric is very different. And maybe here it is important how many of the lines you actually completed. But here we use different metrics.
So my concern, I still don't know if it's good or bad to learn on the completed files already. So is it good or is it bad?
Is it good or bad to learn on the auto-completed files? I don't know.
Yeah,
so it's a nice research question, I guess.
But does it matter if it was already, it was a context where a user
Yeah, understanding how happy developer was is, I guess, tricky. Maybe we could use some fMRI machines or something to to get this data, but it's pretty hard to like embed into a everyday scenario. The question is whether we have some thresholds to understand whether we should apply this code completion model or not. As I showed like previously, the pipeline is that ML's ranking is the last one. So even I'm not sure about the thresholds, but if the confidence of the model was low, it could just be ignored because like the rest of the heuristic sorters would provide something that could be used. They're not bad, you know. They could be improved. So the quality of the model it's a long way to go back. The quality of the heuristic model is good enough. So it's not like it's very bad and we should use machine learning instead. We should use machine learning on top to get this like small increase in the percentage. So if we just understand that the machine learning model is not worth it, so just throw it away. If there are cases when we understand that both suggestions are bad, I don't know. Maybe there are some cases, but I guess suggesting something is better than suggesting nothing. And those heuristic sorters that they have been implemented for over 20 years. So I think they have a lot of if then else statements covering all the cases that could happen. So yeah, but that's an interesting question. Okay, then I think that's it. Thank you very much once again for coming. See you next time.